At the top of your page, you do have the definition for a piecewise function. It's a function that may follow different formulas on different parts of its domain. What does domain mean? X values. So over different x values, we'll have different formulas for each piece of the function. Since these functions are called piecewise functions, and the instructions say to graph each of the following piecewise functions. So number 1, looking at the first piece of the graph, we have f of x equals x squared. What type of function is that? Quadratic. So we need to graph that parabola. And what is hk for that parabola? 0, 0. And our boundary, our last x needs to be at 1. So we're going to have our vertex at the origin, and we need to go over 1, up 1. But at 1, 1, I have to decide, since this is my boundary point, I have to decide, will this be an open circle or a closed circle? So if you notice, is this equal to? No. So if it were equal to, it would be closed. Since it's not equal to, it's going to be open. So 1, 1 is an open circle. And then, so that is as far as we'll go on the right side. So we only want to go to where x is 1. Now, for the left side, we need to finish the left arm. We need to go over 1, up 1, over 2, and up how many? 4. Over 3, and up how many? 9. And put your arrow showing you we keep going up because we wanted all x's less than 1. So there's the first piece of the function. Second piece of the function is f of x equals 3. What does that look like when you graph f of x equals 3? It would be a horizontal line, and that's if we had 2 x values for the boundary. But did they give us 2 x values for the boundary? No. So this is just going to be a point. So where x equals 1, what is the y value? 3. So we need to put a closed circle at 1, 3. And for the last piece, what type of function is that last piece? Linear. What is the y-intercept? 6, and what's the slope? -1. So I need to start at where x is 1. So 1 is the boundary. But I'm just going to use my finger to kind of trace it until I get to my destination. So the y-intercept is at 6. So I'm just going to ghost it with my finger. And if my slope is -1, which way do I go?
Down right.
Down 1, right 1. So here's where I need to start. So the boundary is at 1. So we need to put our point at 1, 5. Now I have to decide if it's going to be open or closed. Yeah, it's not equal to, so it's going to be open. So at 1, 5, put an open circle. And continue with a slope of -1. So go down 1, right 1, down 1, right 1, down 1, right 1. And connect those points with a line. And then put an arrow showing you we keep going down. Because we want all x's that are greater than 1. Now it asks us for the domain, the range, and where this function is discontinuous. So before we decide the domain and range, we do need to see where's this function discontinuous. So continuous function means that when you graph it from left to right, that means you never have to pick up your pencil. There's no break. But if you notice, if I were to recreate this piecewise function from left to right, I would start drawing the parabola first. But what happens when I get right here? I have to stop, pick up my pencil, and go again. So anytime you have to pick up your pencil, it's considered discontinuous. Now when I picked up my pencil, I have to jump to that linear function. So this gap right here is actually called a jump. Now, these two open circles, back to your rational functions, what does it mean in your graph if you have open circles? It's not equal to, and what do we call them? Start with an H. Holes. So those are holes in our graph. Okay, so first thing we have to decide is where's this function discontinuous? Yeah, so it's discontinuous right here where I had to pick up my pencil, which is x equals 1. So I had to pick up my pencil at x equals 1. Now, once you know where your graph is discontinuous, those are the special places you need to be careful when you are writing your domain and range. So for the domain, what does domain mean? The x value. Well, notice this arrow means it keeps going to the left, and this arrow means it keeps going to the right. So it looks like it's all real numbers, but check where it's discontinuous. Notice we have a hole here and a hole here, but what's in between them? That point closes in the gap for us. So our domain is actually going to be all real numbers. So check where it's discontinuous to see if maybe you have a closed point to fill in that gap. Now for the range, it's going to be similar. The range, notice it keeps going up, it keeps going down, so it looks like all real numbers, but we need to check right here at our jump. So we do have y values missing right here, but what do you notice about these y values over here? They're filled in. So this gap or jump, called a jump, so this gap in y values where I had to jump from the quadratic to the linear function, notice it's filled in over here with the quadratic. So what would the range be? All real numbers. So just be careful, check to see where is your graph discontinuous to see if you have any gaps in your domain. If you did, you probably have to do a union with two intervals to write your domain or range. Number 2, another piecewise function. Looking at the first P, what type of function is that? Linear, and we want to start it at -2. So first, looking at that linear equation, what is the y-intercept? -1. So I'm going to go sit with my finger. So I'm going to start right here at -1. And normally, if the slope is -2, we go down to over 1. But is that in the correct direction? Do we want where x is 1? What do we want? We want where x is less than or equal to -2. So instead of going down to right 1, from that y-intercept, I need to go up to left 1, but I'm not there yet. Go up to left 1. So that first point needs to be at -2, 3. Now I have to decide, is this point going to be open or closed? It's equal to, so it closes in. So -2, 3 is a closed circle. And keep going with your slope. So up to left 1, up to left 1, up to left 1, up to left 1. And connect those points with a line. And put an arrow showing it keeps going up, because we want all x's less than or equal to -2. Second piece of the function, square root of 2 minus x, what is that called? Square root. But is that in vertex form? No. So if it's not in vertex form, solve it to get it in vertex form. So vertex form would be f of x equals a square root of b times x minus 8 plus k. Okay, so we're going to get that in vertex form. So this would be f of x equals, a is 1, we don't have to put it. But under the square root, instead of the 2, what should go first? -x, and then the plus 2. Now, what is our b value there? -1. So what do I have to do with that -1? Yeah, notice up here that b value needs to be factored out. So we need to factor out the negative. And when we factor out the negative, what goes inside the parentheses? x minus 2. Okay, so the graph set. What does the minus 2 make it do? Right 2. So instead of starting at the origin, we need to move it right 2. And that is my boundary. So at 2, looking at the symbol beside it, should it be open or closed?
Close.
Closed. So 2, 2, 0 needs to be our starting point. Now if our b value is negative, what does that tell us about that function? Reflects over the y-axis. So instead of going right 1 and up 1, which way do we need to go?
Left 1 and up 1.
Left 1, up 1. Instead of going right 4 and up 2, we need to go left 4 and up 2. But at negative 2, 2, if you look beside the negative 2, that didn't work. If I look at the inequality symbol beside the negative 2, should that circle be open or closed?
Open.
Notice the symbol right here. Is it equal to?
No.
No. So if it's not equal to, that means it needs to be open. So we need to put an open circle at negative 2, 2. And connect those points with your square root curve. And the last piece of that function, what is the parent function for that last piece? Square root. This one's already in vertex form, so it's good to go. But what's the minus 2 make our function do? Move to the right 2. So from the origin, we need to move it right 2. And that's where we need to be. We want to start it at 2. But if you notice, should that point be open or closed? Open, but it's already been closed. If it makes you feel better to put an open circle around it, that's fine, but that open circle has already been closed in for us. Okay, now continuing with that function, we need to go right 1, up 1, right 4, up 2, right 9, and up 3. And connect those points for your square root curve. Okay, now if I have my pencil and from left to right I'm drawing my linear function, what happens when I get right here? You have to pick up your pencil to continue. So it's discontinuous where? X equals negative 2. So that's the place we need to be careful when we're doing our domain and range. So for the domain, it keeps going left, it keeps going to the right. We need to check it right here at the jump. What do you notice about the open circle? There's a closed right above it, so it's going to fill it in for us. So what's the domain there? All real numbers. Excuse me. For the range, keeps going up, but does it keep going all the way down? No, so I see that 0 is definitely at the bottom. We have a point that's closed in at 0, so 0 gets the square bracket. So we need to check to see where does it go up to for that interval. So again, be careful at our jump. So at our jump, we have these y values missing, but what do you notice over here? It fills it in for us. So our domain is 0, not our domain, our range is 0 at the bottom all the way up to infinity because that arrow points upward. So 0 to infinity, 0 inclusive. Okay, 3 and 4, now we're going backwards. They're giving us the graph. We have to come up with each piece of the function. So looking at number 3, how many different functions do you see there? 4 is right. So here's piece 1, piece 2, piece 3, piece 4. We're going to go from left to right. So for this, notice this is what type of function at the very back. What segment 4 is what type? Absolute value. So don't do a slope. Don't do a linear equation with a negative slope followed by a linear equation with positive slope. That's absolute value. Save yourself some work, okay? Okay, so we are going to make, I'm going to make a big brace right here. And we need to come up with the 4 equations. So looking at segment 1, what is the parent function for segment 1?
It's quadratic.
It is quadratic. So the vertex form for quadratic is f of x equals a x minus h squared plus k. Okay, so we need to figure out what is the a value. From the vertex, we normally go over 1, up 1. So it's shrunk. I'm not sure what factor yet, so maybe if I go over 2, how many do we normally go up?
1.
Over 2 and up
4.
4. So it should have been up here, but they only went up what? 1. So a is 1/4, that's right. So a is 1/4. Now, we need hk. So for that quadratic, what is hk? -2, 0. So what goes inside the parentheses? X plus 2 needs to be squared. And for the k, it's 0, so we don't put it. And then put a comma, because after the function, we need to restrict our domain. So looking at this quadratic, how many endpoints does this segment have?
2.
2. So if that has 2 endpoints, you need 2 inequality symbols in your answer. I call it a less than sandwich because I put x in the middle, less than's on both sides. It's always less than every single time. And less is equal to, then you put equal to's under them. So let's check that. So what do you notice about the 2 endpoints? They're both closed, so both of these need to be equal to. Now we need to find the boundaries. So what is the left boundary for x? -8, and for the right one it's -2. So -8 on the left, -2 on the right. So this notation means all x's from -8 to -2 inclusive because those endpoints are closed. Segment 2 is what type of function? Semicircle. So the vertex form for a semicircle is f of x equals a square root of r squared minus x minus h squared plus k. So looking at that semicircle, first of all, what is hk? 0, 0. And what is the radius? 2. Yes, the a value is what? Negative. How can you tell the a value is negative? It reflected over the x-axis. Under the square root, we said our radius is 2, so 2 squared is 4 minus, what do I put for x minus h?
X squared.
Yeah, x minus 0 is just x, so this would be x squared. And for the plus k, do I put plus 0? No. Then put your comma. Now we need to write the domain for that function. And looking at the semicircle, how many endpoints do you see? 2. So again, put the x in the middle. Less than's on both sides. Notice the left one is closed, so what does this less than mean? Equal to. So the left one needs to be equal to. Now, the x values, what's the left x value for the semicircle? -2, and the right one is +2. So -2 to +2, include the -2 because it's closed, but leave the 2 open, so not equal to for the 2. Segment 3 is what type of function? Constant. So this would be f of x equals what value? 4. And then the comma. And technically it has the left endpoint, but I also know it's going to stop right here. Since that line is solid, I'm going to assume it's a closed circle. So looking at that constant, how many endpoints does it have? 2. So put x in the middle, less than's on both sides. Now notice both of these endpoints are closed in, so what do I need over here? Equal to. And that segment goes from what to what?
2 to 5.
2 to 5. And the last function, segment 4, what is the parent function?
Absolute value.
Absolute value. Vertex form for absolute value is f of x equals a, absolute value of x minus h plus k. So the a value, to get that quickly, just find 2 points on your v and count the slope between those 2 points. So what is the a value? 2. Inside the square bracket, well, first of all, what is hk?
8 negative 2.
8 negative 2. So this would be x minus 8, and behind that we would have minus 2, then the comma. And for the absolute value, how many endpoints does it have? 2, so we need 2 inequality symbols in our answer.
And there's going to be,
Yeah, they're both closed in, so they're both equal to
10 and 5.
least to greatest, so it would be
Or
5 to 10.
5 to 10. So the smaller number has to be on the left side, bigger number on the right side. Next one, number 4. Number 4, how many pieces do we have to this function?
3.
3. Here's segment 1, piece 2, piece 3. I want you to come up with that piecewise function for number 4. We'll check your answer here in a moment. Okay, on number 4, segment 1 is what type of function? Linear. So you should have had in slope intercept form y equals mx plus b. So what is the slope for number 1? We're going up 1, right 1, so that would be positive 1. So that would be a 1x, and the y-intercept would hit at 3. So that was x plus 3. Now looking at segment 1, how many endpoints does it have? It's array, so it only has 1 endpoint. So that means you'll just have 1 inequality symbol in your answer, either a less than or a greater than. So what's the case here? We want x is less than negative 1 or x is greater than negative 1. Less than or equal to negative 1. Segment 2 is what type of function? Absolute value. So here is a point. Here's the point. What is the a value? Negative 4. And what was hk? 0.8. So what do I put for x minus 8? Just x. Don't put the minus 0. And for the plus k? And for that absolute value, how many endpoints does it have?
2.
Yeah, there's understood to be a close one right here. So since it has 2 endpoints, you need both of the less than. Now notice the left one is open, but the right one is closed. So make sure the right less than symbol is equal to. And the x's, what's the left x value? Negative 1, and the right one is 3. So negative 1 to 3, include the 3. And the last one is constant, so this would be f of x equals negative 4. That has how many endpoints? 1. We have 1 endpoint, 1 arrow. So we'll have 1 symbol in our answer. So we'll have to decide, do we want x's that are greater than 3 or x's that are less than 3? Greater than or equal to 3. The last 2, we just have to evaluate. But the only trick is, make sure you're evaluating the correct piece. So number 5, you want to find f of 6 plus f of negative 3. This is normally f of x. So they're saying x is equal to 6. So I have to decide which piece do I use. So look at your domain. 6 and 6. So which one is true? Is 6 less than or equal to 0 or 6 greater than 0? Greater than 0. So I have to use that bottom function for the first one. So this would be 0.5. What are we substituting in for x? So this would be 6 squared minus 5. That's for f of 6. Now we have to add to that f of negative 3. So this is normally f of x. So here x is negative 3. So now I have to decide, do I use the top one or bottom one? Top one, because negative 3 is less than or equal to 0. So that top function is absolute value. 2 minus, what are we substituting in for x? Negative 3. And when I subtract a negative, that becomes plus 3. Okay, so that's what I need to see. I need to see this, and I need to see a little bit of scratch work. So, starting with the parenthesis, what is 6 squared? 36. What's half of 36? 18. Bring down your minus 5.
13.
Simplify your absolute value. 2 plus 3 is 5. Absolute value of 5 is 5. So I need to see some work with this. Left to right, 18 minus 5 is,
13.
and 13 plus 5 is 18. So if you just put 18 as the answer, you won't get credit. You have to have work to back up or support your answer. So make sure you have work to get credit. Last one, number 6. Same thing, but now we have 3 of them. So for the first one is g of 0. This is normally g of x. So if x is equal to 0, I have to decide, does 0 equal negative 2 or is 0 not equal to negative 2? Not equal to, so I have to use the top one. So that would be 0 plus 3 over 0 plus 2. Add to that. The next one would be g of negative 2. So if x is negative 2, do I use the top one or the bottom one? Bottom one. So that answer is just 1/4. You don't have to simplify anything for that one. So you only use the bottom one if x equals negative 2. Then for the last one, we have x equals positive 2. So for x equals positive 2, do we use the top one or the bottom one? The top one. So that would be 2 plus 3. Oops, that's funky. 2 plus 3 over 2 plus 2. Now that's what I need to see. Then I need to see some work with that. So for that first fraction, what does this simplify to? 3 over 2 plus 1/4 plus what? 5 over 4. In order to add fractions, what do we have to have? Common denominator. What's the common denominator between 2 and 4? 4. So this would be 6/4 plus 1/4 plus 5/4, which equals 12/4, which equals 3.